Welcome! Today we're going to solve a classic physics problem about minimizing drift when crossing a river. Let's first read the problem statement. Let's break down this problem. We have a boat that's trying to cross a river. The river is flowing with velocity v sub r. The boat can move relative to the water with a velocity v sub b, which equals v sub r divided by n, which is 2 in this problem. We need to figure out at what angle theta the boat should move to minimize drifting down the river. Let's establish our coordinate system. The river flows in the x direction, so the river velocity is v sub r times the unit vector I hat. The boat moves with velocity v sub b at an angle theta to the river flow, so its velocity vector is v sub b times the quantity, cosine theta I hat plus sine theta j hat. The resultant velocity of the boat relative to the shore is the vector sum of these two velocities. This means the boat's resultant velocity has components v sub x equals v sub r plus v sub b cosine theta, and v sub y equals v sub b sine theta. To minimize drifting, we need to understand what causes it. The drift is related to the angle phi that the resultant velocity makes with the x-axis. This angle is given by the tangent of phi, which equals v sub y divided by v sub x. Substituting our component expressions, we get tangent phi equals v sub b sine theta divided by the quantity v sub r plus v sub b cosine theta. To minimize drifting, we want to minimize the angle phi, which is equivalent to minimizing tan phi. To minimize tangent phi, we'll take the derivative with respect to theta and set it equal to 0. Using the quotient rule for derivatives, we get this expression. After some algebra and using the identity cosine squared plus sine squared equals 1, we can simplify to v sub r cosine theta plus v sub b equals 0. Solving for cosine theta, we get cosine theta equals negative v sub b divided by v sub r. Since v sub b equals v sub r over n, and n equals 2, we get cosine theta equals negative 1/2. So we need to find the angle theta, where cosine theta equals negative 1/2. This gives us theta equals r cos of negative 1/2, which is 120 degrees. Let's visualize this. When the boat moves at an angle of 120 degrees to the stream direction, the boat's resultant velocity is directly across the river with no downstream component. To summarize, to minimize drifting, the boat must move at an angle of 120 degrees to the stream direction. This is equivalent to 60 degrees upstream from the direction opposite to the stream. This problem is a great example of vector addition in physics. By carefully analyzing the relationship between the boat's velocity relative to water and the river's flow velocity, we found the optimal angle to minimize drift. Remember, minimizing drifting means we want the resultant velocity to have as small a downstream component as possible. The mathematics showed us that this happens when the boat moves at exactly 120 degrees to the stream direction.